Hi everyone, thanks for stopping by to today's stream. My name is Laura, if you haven't met me before. I work for Prefect, and today I want to talk to you a little bit about how to set up your execution layer. So we'll talk a lot about what that really means, and also look at a couple different ways to do it. But before I even really get started, I want to point out that I do have sort of a written guide that goes alongside this video as we're going. And I put the link for it in the chat, but you can also find it on coda.io/@Laura-Lorenz. You'll be able to find it there. And I may refer to this during the stream to make sure I have all my ducks in a row and I'm doing the right step that we're supposed to be on. So should be pretty good after, or a good companion to this as we are going. All right, so the whole point of today is that we're going to talk about how to take your prefect flows and the tasks in your prefect flows and move them to a greater scale of execution. So maybe a lot of you have already used the Prefect Core API to make flows and run them on your local computer. But I would love to teach you now, or talk to you a little bit now, about how to get that into a bigger scale. Particularly, I'm going to talk about how to deploy different execution layers, especially Dask based execution layers in GCP. And if you're an AWS person, there is a blog about that too on our Prefect blog by one of my coworkers named Kingsley. So if you're an AWS person, don't worry, we've got you too. But today we're going to talk mostly in GCP land. And if you don't know anything about GCP, that's okay too. We'll go over a little bit as we go. All right, so what I want to show everybody first, make sure I'm going along the right way here, is just the flow that we're going to be working with and a couple basics. So in my case, I have, spoilers, I have this flow here. So probably this should look familiar to people who have written prefect flows already. It's this flow named dash example, because I'm going to use it mainly for showcasing the power of Dask. In particular, the reason why this flow is good for that is because it's a diamond-shaped flow. So what's going to happen is that, we have this inc function that makes numbers go up, this dec function that makes numbers go down, this add function that adds numbers, right? But what's going on down here with this map syntax here is that we're going to do that inc function 100 times, that dec function 100 times, all with different inputs. And then we're going to take those inputs and add them. So there's going to be like 100 different ones of those that depend on those original ones finishing. And then at the very end, we're going to have a task that sums up all of the things that got added thus far. So this is our reduce step, if you imagine this as a series of map and reduce. And the shape of this all turns out to be like a diamond type shape. So that's the flow, and you could definitely run this locally with flow.run right in a Python process. But what I want to go through now is sort of 3 different ways to kind of scale that up. And without too much further ado, what I'm going to first show you is on the second tab here, which is to run Dask locally yourself. So this is still, in this situation right now, we're still going to be trapped in our laptop, but I'm going to show you how that kind of has an analog to going into the cloud. And basically what it boils down to is, I've got my various little windows set up back here, is that I'm going to have one window here in my tmux right now running the Dask distributed scheduler. And then I'm going to have these 2 other windows over here running workers. And this Dask scheduler and Dask worker comes with the Dask distributed install. And then I'm going to run my flow against that scheduler. So the first thing we need to do is make sure that our scheduler is turned on. So I'm going to come down here to this window and press enter just to run this CLI command dask-scheduler. You'll see some output here that is like, hi, I'm a scheduler, right? Waking up. And then similarly, if I come over here, then I have, it's a little crunched because they're small, but I have these commands dask-worker that specifies the address where the scheduler can be found. The situation here is these workers are going to grab work from the scheduler, and then also in our case, Prefect is going to submit the work to the scheduler. So we're like looping down a little bit here in my little example. And the important thing here is that the workers need to know where their scheduler is. This host is right here. So let me make sure 10, 255, 253, 2, cool. Make sure that these are synced up. And then I just randomly put n threads equals 1. So there's only going to be 1 thread per worker. It's kind of a whole other conversation about task optimization and how many workers and how many threads. We're just going to talk kind of about deployment today, but that's a talk for another day, I think. But I'm going to press enter here on these two, and you'll see some output point out, and you also see that my scheduler sort of, woke up because it got pinged by the workers that they are subscribing to whatever the desk scheduler throws at them. So again, if I go back over here to Sublime Text, what I am going to run here is this file called daskflow1. You can see I've got it kind of queued up here in my terminal. And this is just importing the flow from our source file. And you'll see for all these configuration flows, I'm just going to do that so we don't have all the extra flow code in our way. And the important points that are going on here is that I'm importing the Dask executor class from Prefect engine executors. And then I'm passing it this same address, right? So let's see if we've got room to look. But yeah, 10, 255, 253, 2, port 8786. So this address is telling this flow, or rather this Dask executor object is getting this address that corresponds to this Dask scheduler that I just started. And then in our last line here, line 7, we're actually going to call flow.run and pass in as the executor for this run, the executor that we just created on line 5. So this is how this is all tying together, that the work is actually going to be run by these Dask workers through this Dask scheduler because I configured the Dask executor right here, right? So that's sort of how it all goes together. So let me make sure I'm in the right window. So if I press enter up here, this is that same file that we were just looking at, and give it a go, then you'll see all sorts of, this is the fun part, I guess, but all sorts of work is going on. You'll see my workers are having a bunch of their own task output. You'll see the scheduler is giving some of its scheduled output. And then up here, we actually see the output from the flow runner that is submitting the tasks to our distributed scheduler. So this is an example of how to set up a Dask scheduler just locally and configure it on the Prefect side, right, by address. So you can imagine if there's a Dask scheduler somewhere else on the internet that maybe you didn't set up, maybe your IT or DevOps set up for you. If nothing else, if it's something that's public or at least in-network for wherever you're going to run your flows, you can just drop in this address and pass that in as the executor and get your flows to run over there, right? So, but what we're going to do is actually, we're going to do the IT DevOps ourselves right now. And we're going to take what we see right here and actually move this Dask executors, or rather these Dask workers, this Dask scheduler, not have them running on our local computer. We're going to have them running in GCP. So that's what we're going to do next. Here's the next section. And if you're following along, that's going to be this second page up here. Let's scroll up. Static Dask cluster in GCP with Helm. So just to quickly talk about this word too, static, it will make some more sense later as we keep layering things on, but Dask has a lot of different ways to configure it, like a ton. In fact, we're really just at the tip of the iceberg, even in just this stream. But I would say two big categories is whether the workers for your Dask cluster are static, as in they're always up, or they're ephemeral, as in they only wake up when they have work to do. So there's plenty of tooling around having ephemeral Dask clusters, which is pretty awesome, and can make your bills a lot lower, right, for your cloud. But what I'm going to show you right now in this little section here is how to set up a static Dask cluster. And in particular, we're going to use Helm, which is something that's going to work on top of Kubernetes. And then we are going to deploy all of this to GCP, Google Cloud Platform. That's going to be our cloud service of choice, as opposed to like AWS or Azure, for example. So in the sort of text here, I actually have a bunch of pre-steps that I did to get set up. For example, you're going to need a GCP account. And I've got myself set up over here. And this is what the Google Cloud Platform dashboard looks like when you're logged in, right? And in my case, I have already created a project in GCP called Execution Layer Demo. I've pre-cooked a couple of things in case there's any technical drama, but this is a pretty standard way that this dashboard may look. You can customize it, of course, but that's neither here nor there. All right, so you're going to need to have a GCP account, get that going. And then, whoops, over here. The next three setup parts are all related to your CLI environment. So there's three SDKs that we're going to want to install: gcloud, kubectl, and Helm. So gcloud is the CLI to interact with Google Cloud Platform itself. It's made by GCP. It's how you could do anything that you do in this console, like if I click around and create clusters or click around and create whatever, anything that you can do in this web console, you can do with gcloud. That's sort of the relationship there. The other thing that you need to have installed is called kubectl, and this is the CLI for interacting with a Kubernetes API. So in our case, I'm going to be deploying this Dask cluster on Kubernetes, or using Kubernetes. And to do so, I'm going to have to talk to the Kubernetes API a couple times. So that's what this is about. And if you've got that set up, you can actually install it as part of a sort of sub-component package from gcloud too. But that's how I would recommend it if you're installing it from gcloud. And the last thing that we need to have installed is Helm. And Helm is basically a tool. In particular, we're going to be using the CLI from it for finding and deploying Helm charts. And Helm charts are like bigger packages of configuration for how a bunch of different Kubernetes resources might, play together. And the fun part here is that the Dask people have already created a Dask Helm chart that already defines all of the stuff that needs to be made in GCP in order for you to have a static Dask cluster with configurable numbers of workers and configurable numbers of other things. So that's what we're going to use today. Thank you to the Dask people for making that. And all of these CLIs are going to be necessary to do so. Okay, so we're kind of going to layer on gcloud, then Helm. We're not going to really get to kubectl until a little bit later. So we're going to be switching a little bit between the different CLIs depending on what we need to do. And the first thing that we need to do is make a cluster at all for this Helm chart to be applied to. So we need to provision the compute resources that exist at all. Conveniently, GKE will do a ton of the Kubernetes setup stuff for you. So GKE stands for Google, does it stand for? I think it stands for Google Kubernetes Engine. And this is a specific service to provision a working Kubernetes master node on your cluster and some other stuff without you having to do any of the Kubernetes install. So that's a really nice thing about GKE. So otherwise you would be setting up compute and then installing Kubernetes yourself. So we don't need to do that because GKE exists. So in this example here in 1A, I've got a gcloud command, and gcloud commands sometimes get a little long because there's a lot of sub commands and sub commands. Since there's a lot of products, right, in Google Cloud Platform. So they have a lot of stuff in their CLI, right? But what we're going to do here, you can see gcloud, containers, clusters, create, then the name of your cluster. And there's a couple different flags that you can set, of course, to configure these things. But what I'm going to do in this demo here is set the region, which either region or zone is required. Then I'm also going to set the machine type. It defaults to a sort of like micro type instance. So I'm bumping it up a little bit. And I'm going to go ahead and even try running that back here. But I do have my pre-cooked one in case of emergency, right? So let me get my terminal out and just make it a little bit smaller for a second so I can reference this. So gcloud container clusters. I get the plural singular messed up a lot. Create. And I already have one called demo cluster. That's my pre-cooked one. So I'm going to call this live demo cluster. And same thing, US East 1, machine type, what did I say? N1-standard-2. N1-standard-2, right? So I press enter here. There's going to be some output, but I also want to run over here really quick so you can see this clusters pane right here. And as this gets going, eventually we can get to a point where we can refresh and we'll see this cluster appear. So there's a bunch of background stuff going on here with the loading screen. But eventually at some point we'll see our cluster show up. So this can take a little bit. So I'm just going to show us really quick what a cluster definition kind of looks like. So, I'm definitely not a GCP expert. I'm the kind who maybe clicks around a lot to see what's going on. But I definitely would say that there's a lot of good information in here. The basic thing going on here is that we have this cluster of compute, which in it has node pools, which are Kubernetes nodes. And these Kubernetes node pools can execute work for us. So all of this setup you see here is just from that one command that is running in the background right now that you don't have to do at all. Otherwise, you would have had to set up a bunch of this stuff yourself. So so I definitely recommend clicking around, seeing what is being set up for you back here in Compute Engine, but if you're interested. But the exciting part is that the GKE service is taking care of all of that for us, so we don't really need to go into all the details if we don't want to know. So let's see if my cluster is showing up. Of course, it's taking a long time since we're in the live show. So I'll let that go for a little bit and talk about what's going to happen next, which is that we're going to use Helm. So the way that Helm works is after you install it, you can set up different repositories of Helm charts that you can search. And then you can install them based on these names, right? So if you're used to Docker registries, this is kind of like there's a Helm registry, right? So this is where the Dask people have created a Dask Helm chart. And we're going to install that into our cluster is what this install step is going to do. And then you can give it your own name. I have this -- auto generate name. It's kind of up to you. And just to show you the cooked version of this, for example, over here in Helm, demo cluster, if you go down to workloads, this will show you the deployments that have actually been submitted. So here you can see that I have a Dask 1593 blah, 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 blah scheduler, Dask 1593 blah, blah, blah worker. That first part is the name that in this case I auto-generated earlier, but you could have it be named after something that is actually meaningful to you. So go back to my cluster, see how this is going. How is it going? Let's see. Live demo cluster, blah, 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 blah. Oh, it's telling me to update. I don't see it. What happened? G-Cloud containers cluster, region US East 1, machine type, blah, blah, blah. Let's make sure that we are the right... Yeah, we're in the right project. Okay, so that's good. And I would have expected it to show up here, but I don't see it. So we will carry on with the pre-cooked one for now until and unless it decides to reveal to me where it has gone. Okay, so the situation back here with the Helm demo cluster that I set up before. These steps, as mentioned, is this Helm install Dask/Dask, and then again, auto-generate name or your name if you want. So if I run this again, it's going to recreate another set of, it's going to redeploy, basically, make a new deployment. So I won't necessarily do that, but I do want to show you what the next step is. So you can actually see some of the Helm output, which is what you might do to anything that you've deployed with Helm after you've done the first installation, which is Helm upgrade. So when you first do Helm install, you're going to actually see 3 services here, scheduler, worker, and another one called Jupyter. And if you read the docs around Dask Helm, then you'll see that show up. And what I have actually done, among other things, is apply an update to my Helm deployment here that took some config from a file, including the direction to not include that third one I just mentioned, the Jupyter deployment. So normally it comes with 3 things, and I decided that I don't want the Jupyter deployment for myself, so I edited my config file to show that. So if we take a look at this config.yaml, where that is going on is down here on line 13, where I set Jupyter to be disabled. And then a couple other things that I included in this config file. This is pretty minimal config file, but there's some other stuff that you can set, which is described in the Helm docs, is to set the number of replicas for my workers. So how it should horizontally scale is a way to think of that. the resources that those worker pods are going to requisition and what limits they have. So in this case, I'm saying that these are equal. You can play games with this to control how Kubernetes will try and recover from renegade pods, but to only use one CPU and only use 3 gigs of memory. And then this is the important part that I really want to point out, especially for the people who are Prefect users on Dask. So the Dask Helm chart is awesome. Again, thank you, Dask people. But if you are using anything outside of what's in the base Dask image, then you're either going to need to use a different image for your Kubernetes deployment. So you'll have to change that configuration in config.yaml and also like build that image separately. Or there is this convenient environment variables, extra pip packages. There's another environment variable called extra conda packages where you can specify pip or conda packages that you want the Dask image to install for you when it wakes up. So that has sort of already been set up. So if we have something really limited here, in my case, I only need to install Prefect because my example flow doesn't have any other dependencies besides Prefect, then it's really easy to just throw this in here. If you have something really complicated, you might want to look into building your own image instead and sending that as config. So that's kind of up to you, which is better, but this is a really, quick, easy, fast way, and it's very clear from this config file what's getting installed too, which I like. So if we jump back over here, my pre-cooked one here already has this config file applied, but you can see what it might look like, the output. I need to grab this name, right, which I probably should have called it something more helpful in retrospect, right, because that's going to be the target for Helm. And then I'm telling it to use the Dask Helm charts, but I'm also telling it to look for a file in here called config.yaml, and that's the extra configuration that I want to apply. So those are the pieces that are going together to tell Helm, to tell Kubernetes to apply these changes, right? So Helm upgrade, my mistake, it's not update. Upgrade, enter. Okay, so upgrade failed, has no deployed releases. I don't know if that's because I already had this config out. I've gone off the rails now, so we're doomed to a series of technical snafus. But under normal circumstances, you'll see output talking about how the upgrade has succeeded and has been applied. And you'll see changes go on back here potentially as well. So this is our Helm deployment. So if you use Helm to get deployed, the whole point of this is that now we have a scheduler on GCP, right, that we want our flows on our laptop or wherever they are to use to run. So in this case, if I click into this scheduler here, you'll see way down here that I have a load balancer type endpoint. So this is a public IP that can be used to access this scheduler. So I think the Helm chart will automatically create these services. I got impatient and exposed it myself, actually. But you can grab this, and then you can drop that into that exact same place for your executor, except now this is a public address, right? So I'm just going to click between these two, right? Before we were using a local Dask executor. This is a local address. This is a public address. So there isn't really many other code changes for our static Dask cluster. We're still just specifying where the Dask executor is at. It's just at a different place. And we did all those pre-steps with Helm to actually get it set up. So we can clear out this, give it a go. I called this Dask Flow 2. And hopefully see that it will execute on my cluster. So you can see that it went and did this work, not here, but on that cluster elsewhere. If you do a lot of Dask work, you'll definitely see this output here, which is sometimes a lot longer, which is differences in packages between your client, which is my computer right now, basically, the scheduler or the workers, which again, the scheduler and the workers are these two different workloads, right, in my cluster. So it's really important to have, it will warn you whether it's really, really important or not, but it's pretty important to not have variation in these, particularly related, at least in my experience, to the pickle versions between different Python versions. So you may notice in the walkthrough guide that my Conda environment I purposefully created with Python 3.8 because earlier when I was working on this, these the default image for Dask, the Helm chart of Dask, has Python 3.8 in it, and so I needed my client to also be in Python 3.8 in order to meet the same pickle protocol restrictions. So that's the reason why I did that back here. Okay, so not the smoothest, but hopefully you got the idea that you can use this Helm chart and use this Helm CLI to deploy this Helm chart. You can create this config.yaml file with some minor changes, or you can, go ham with different Docker images and completely customize it, but still use this Helm chart to deploy it. And then you can, more or less easily get all of these services here that you need on a cloud that can then scale out, that many people can connect to, and then that work can be done there instead. And it's just this one quick line. If you're just going to run flow.run, you just change the executor address and nothing else. So that's the idea of the static Dask cluster. So there's two other styles I want to show you, but I want to take a quick architecture interlude before I explain them, because the other two styles I'm going to show you depend on an orchestration layer. In particular, I'm going to be using Prefect Cloud, though you could also use Prefect Server for this. What we're going to set up next is to have Prefect Cloud, with a little help from the agent, be the one that's actually doing the flow.run step. So we're not actually going to run a Python file that says flow.run. We're going to tell Prefect Cloud that it should have the flow be run. And then this agent is going to be the one that controls some details about how this is deployed. And we're going to do kind of a simple case first where the agent kind of does a vanilla version of it with little work by us. And then we'll do another example where we use something called an environment. So this is a Prefect object called an environment that can give us a little bit more control over how the workers are being spawned. And I mentioned a little bit down here, but the important thing, which you're going to start seeing here, because I'm going to start throwing tokens around, is that Prefect Cloud is this public API, right? You can access it over the internet, but you need to authenticate to it, especially if you've got tons of different distributed things all over the place. They all need to be able to authenticate it. So Prefect Cloud can be like, yes, you can run a flow, or no, I don't know you. Why would I let you run a flow, right? That type of thing. So whereas for our static Dask cluster, that was handled by gcloud to authenticate to Google Cloud for us, Prefect Cloud is going to want to authenticate to all of these other services using tokens that you create in Prefect Cloud. So all the things that we make by the Prefect CLI, such as the agents, are going to need to be authenticated with a token that you can get from the Prefect Cloud UI. So that's what I wanted to really get across with this picture in particular. Okay, so let's take a look over here. So I have this. This is Prefect Cloud, if you haven't seen it before. Also looks very similar to Prefect Server, if you use Prefect Server, just a couple extra bells and whistles. And I already have this account, right? But you can make a free account and set up a couple things, which to make sure I don't miss any, I will mention now from this list. Okay, so you'll need your Prefect Cloud account. You also need a project in that account. So in my case, I have this project called Execution Layer Demo, right? So I made that through the UI. And then I authenticated to Cloud with Prefect Auth login with a user token. So I've already done that over here in my terminal. I ran Prefect Auth login and connected with my user token, which I created from the UI as well. So those are the logistical parts. But then the configuration thing that we want to emphasize here is once we start getting this orchestration layer in between us and our flow, basically, we're going to need to layer on a concept called flow storage. So in this case, you'll see in this little example, it's easier if I pull it up here. I'm taking the same flow that we've been working on this whole time, but I'm setting its storage attribute to be this class Docker. And in my specific case, I'm giving it a registry URL that aligns with my project in GCP, right? So I'm actually going to show you over here that this is my container registry in Google Cloud Platform. So just like Docker Hub has one, GCP has one called GCR, right? Google Container Registry. And what I'm going to do is send all of my flows, the built object of the flow there. And the exciting part about this is then Kubernetes can get a hold of those flow objects and work on them without me being involved. And then this last step here, line 7, this flow.register, for people who are used to cloud or server, the orchestration layer, this is no news. But this is what's going to actually register this flow, that it exists, and some metadata about it, for example, where the storage is at, in Prefect Cloud, so that if from the Prefect Cloud UI or from the Prefect CLI, we say, hey, Prefect Cloud, can you start this flow? It has this information about how it should go about doing that. So this register step is relevant for any flows that you want to run through Prefect Cloud or through Prefect Server on the orchestration layer. So I'm going to execute this, and we'll see some output here because I set Docker as my storage. We're going to see that this Docker image with my flow in it is going to build right here. So relevant point, you need to have Docker installed to use Docker storage right now. There actually is some great changes related to, what was the term we gave them? Non-Docker storage for containerized deployments. I'll have to look it up, but we have a long name for if you don't want to build your Docker image every time you want to deploy a flow. But here you can see I've got some output here. I built this earlier, so it actually went really fast and built from cache. But it pushed the image to my registry. That's what this one line in here is about. And then it also gives me this output of where my flow is registered. So those are kind of like the culmination log lines from those two different steps. This is sort of the culmination of our build step, and here is where it actually got registered. So if I refresh here, you'll see that now there's actually stuff in my GCR dashboard. If I click on flows, you can see there's one called desk example, which matches the name of my flow. And here is the image itself that just got built and pushed to this registry. So since this is up in GCR, any of my Kubernetes clusters can access this flow in this storage format, and that's the whole reason why we're doing storage at all. There's some alternate storage types. Docker is one of them. You can use S3, you can use GCS, so you can use more sort of file type feeling ones. But definitely take a look. Docker storage is pretty easy if you use Docker a lot, though. Okay, so now that this is up here in the cloud somewhere, we'll also see if I give this page a refresh over here, that my flow has also been registered to Prefect Cloud. So this is like a UI vision of the representation of this flow in Prefect Cloud, what it knows about it. So, it knows some metadata like what its schedule is, what version it's on. If I click in, it knows, any past runs, which of course is none right now because I haven't done anything. But we can see, for example, the metadata about what tasks are supposed to happen, what class they are, etc., stuff like that. So that's all now visible in here from the process of registering. And we also can now use this run button, or even more conveniently, this quick run button, to actually trigger a run. So if I had put this on a schedule, Prefect Cloud would schedule it on my behalf. Since right now it's ad hoc and it's quicker for me to show you anyways, I'm going to press quick run, and you could also use this to run any ad hoc flow at any time. So by pressing quick run, or run in the UI, we now have a flow run object. Right now we're seeing it represented in the UI like this, that has been scheduled. But an important point here is that it's not doing anything yet. Importantly, it's not in submitted state, which for cloud people or server people know that we want to get in submitted state and eventually finished, right? So it's only been scheduled. So an important piece, and I'm going to jump back to my architecture interlude really quick, is that we must have an agent in the case when we're working with Prefect Cloud, to ask, should I do this work? And then it's going to be responsible for polling whether work should be done and then triggering the environment or passing that off to the executor. So we need this agent object to exist, this process rather, to exist somewhere. And right now I don't have one, right? So what I'm going to do is install a Kubernetes agent. So there's a series of agents that are in the Prefect API, the Kubernetes agent, the Docker agent, the Fargate agent, if you are Fargate people. And each of them have install and a start step. So here, I'm going to show you what the output is first really quickly. A Prefect agent install Kubernetes -t with my runner token, which is a token. Again, we need to like piece all of our various distributed items together with these tokens that we generate in Prefect Cloud. So that's what that is. And you'll see I have this --rback. So pressing enter here is actually going to create a file, which is actually a bunch of manifests for some different resources that we would want to make against our Kubernetes API. So in this case, it's defining, for example, a deployment type. This is kind of Kubernetes talk, but a deployment type of Prefect agent. It's also going to, let me scroll down here. You can see there's a little sort of like header, HR line. We're also going to make this role and scroll down, role binding. So the thing going on here is that a role describes some permissions that an object may need to have, and a role binding actually binds those permissions to a specific object. So these three things are going to be needed for us because we need the deployment to exist in the first place because that's our agent. But then we need this permission and these permissions to be attached because the thing about the Kubernetes agent is that it needs to have permissions to create other Kubernetes jobs. That's how it's going to do its work. In the most basic sense, it's going to create Kubernetes jobs for the flow to execute indirectly. And then later we'll add on an environment to make that more complicated. But if nothing else, it needs to be able to make Kubernetes jobs specifically to create flow runners. So to actually do this install against our cluster, which let me get myself showing you all something over here. Oh, my live demo cluster showed up. Exciting. What I'm going to show you over here is in this cluster called Cloud Demo Cluster. Oops. Oh, this is just the clusters view. But you'll see that I have these two workloads in Helm Demo Cluster, but nothing in Cloud Demo Cluster. So I'm going to create this Kubernetes agent in my Cloud Demo Cluster for convenience. On that point, if you ever are in a world where you have multiple clusters, which I'm in right now, I mentioned this in the beginning over here, I think, but you may need to change what cluster you are looking at right now, which it looks like I didn't write here, but I put in my secret notes on the other computer so that I don't forget. I'm going to make sure that I'm in the right cluster. I'm authenticated to the right cluster and doing actions against the right cluster right now. Git credentials. Cloud Demo Cluster is the name of the cluster that I want to be working with. Oops, and I need to tell it that the region is US East 1. Okay, so two things happened in the output. It says fetching the auth data and then kube config entry generated. So what's happening here, I'm finally pulling out kubectl right now, is that this process, this gcloud container clusters get credential, blah, 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 among other things, is going to reconfigure what my kubectl is pointing at, which Kubernetes API server it's pointing at. In my case, I have multiple clusters, all with different Kubernetes master nodes in them. So in my case, one other sort of tip that has helped me, especially setting up multiple demos, is this kubectl space config space current context, which is going to show you which kubectl config object that we are pointing at right now. So I can confirm that I'm looking at the cluster that I want, that I set up for my cloud demo, separate from my Helm demo. So that's just a little bit of logistics there for my specific case that I have multiple clusters. If you don't have multiple clusters, then you may not need to worry about any of that at all. Okay, so all of that to get to the situation where I can, let me actually clear this out a little bit so we can see, where I'm going to take the output of this and pipe it to kubectl apply -f space dash. So what's going on here is that this is kind of our only real time we're going to see kubectl in action. If you get more into Kubernetes, you'll use kubectl directly more often. But here I'm setting kubectl, or I'm calling the kubectl CLI, and then apply takes some configuration file and applies that to the Kubernetes master node to make those resources. In my case, we looked before at all the resources that came out of the output of this, which was the deployment for the agent, the role, and the role binding, right? So I'm going to pipe that into kubectl apply and set that as the input for my -f file. You could also save the file or even save the file and edit it if you wanted to, and then apply that instead. So in this case, I'll press enter and see that it gives me some output that some things have been created. Those specific things actually that we read the file to create, this deployment, this role blinding, right? So now if we jump over to here, our workloads, we should see some stuff starting up. And in fact, this Prefect agent started, and you'll see something else happened. A Prefect job started, and I'll tell you right now that the reason that happened is because I had this flow waiting to start, waiting for an agent to see it, right? It was in its scheduled state, and nobody was, calling on the phone if it should start. But once my agent woke up, then it actually picked up this work. It picked up from Prefect Cloud that this work should happen, and then it spawned this Kubernetes job. Again, no real configuration from us, except that we applied that stuff from the output of Prefect agent install. And now it's actually doing that work. We can see that the green dots have begun, right? So that is the most sort of like vanilla situation regarding just setting up the Kubernetes agent and letting it kind of do its thing. This will only really work for, flows that you don't want a lot of control over what that Kubernetes job is like. And in particular, right now, this Kubernetes job, it's not a Dask worker. It's just like a worker. It's just a Python process that's, doing its best. But if you have, for example, in our case, this diamond-shaped flow that has a lot of stuff that needs to all get done, preferably in parallel, then the whole reason we've been talking about Dask this whole time is that we would rather execute this on Dask workers so that they can take advantage of the parallelism that Dask provides. So the last bit I want to show you here at the end is, in this last step, is a way to configure, using Prefect, a Dask Kubernetes environment, which is going to do all the magic behind the scenes for you, basically, to set it up so that your Prefect agent is going to spawn jobs that run the flow runner, that spawn jobs that have Dask workers in them. So your task can actually run inside Dask workers. So instead of setting up all the Dask stuff ourselves, we can instead take advantage of the fact that Prefect has taken some of this boilerplate away from us. And if we take a look at the bigger version here, Dask Flow 4, right? You'll see that between Dask Flow 3 and Dask Flow 4, the big change is just that we've included this import for Dask Kubernetes environment, and we've associated that with this flows environment before we register it. So there is some other configuration you can set here to pass on to the Dask executor in particular. But I'm going to give this a run real quick so we can get everybody started. And the the steps here are basically very similar. This Docker file needs to build that has, or rather this Docker image needs to build that has this flow inside it. It's going to be pushed to, again, my GCR registry. I gave it a name after my project, but it's going to have this metadata in it that the agent knows how to understand, that the Dask Kubernetes environment should be the one it uses when it actually starts the work. So this all happened, again, pretty fast back here because I already had some of it cached. But we can take a look at a couple of our places. For example, we can see that we have a new image in here in flows/Dask example that happened just now as opposed to 12 minutes ago. And actually, if we jump out here and look at our flows and give this page a refresh, we'll see that we're now at version 2, right? So there's 2 versions of this flow, the one that we are technically still running right now, and the one that we've new and improved, put a Dask Kubernetes environment on it. So we're going to let it do that instead. So clicking in to our flow, I can press run again on this. Ooh, I lost some of my CSS for some reason. Wake up. My image is lost. If I press quick run here, I'm now going to run the new version here of my, I hope I clicked on the right version. Flows. Right, Dask example. Okay, and my agent, actually, my same agent, we can actually use. We don't need to like reconfigure an agent or anything. So we just need to wait for this agent to pick up this job, and actually we'll see that some new resources has appeared. Here is this Prefect-Dask job, which again is that Dask Kubernetes connection going on that's actually creating the Dask workers and the Dask scheduler instead of just running right in process. And we can then take advantage of the fact that Dask is going to be a lot faster for us because it's parallelized. So again, we can see in here, in fact, let me filter this out just so that we don't have this other stuff. This is everything that's going on in this demo, in this cluster right now that I'm demoing with, right? We have an agent, we have the job from our prior run, and we have this Dask job and these Dask workers that are, this one is creating its container, this one is already running, but this is where the actual work is going to happen. So this is going to be where the Dask workers actually are. So you give it a couple refreshes now, everybody is awake. So the situation now, we see that both of these are running. I should have given them a better name, but you'll see that Magnetic Fossa is the one we started first that didn't have the Dask Kubernetes environment set. And Gainful Collie is the one that does have the Dask Kubernetes environment set. So both of them are currently running, but with different configurations, right? So let's see if I can open both of them in different tabs just so we can take a look. So here we've got Magnetic Fossa going, working on all of these decrements. We're at 86. All of these increments, that one got to 100 already. And then over here, Gainful Collie, right? We'll see that this one has already made a bunch more progress, and it's only been 1 minute and 30 seconds, whereas this one, it's been 6 minutes and 10 seconds, right? So this one is already got 100 of these and 90 of these. So, you know, this is kind of a high level visual view of what's happening under the hood. It might be nicer if we had like all the logs running really fast, right? But the situation here is that Gainful Collie is running on the Dask Kubernetes environment, so it can take advantage of parallelism. Our agent already set up that there should be Dask workers that get spun up to parallelize this work, and that's why this one's going a lot faster. Whereas Magnetic Fossa, again, we just used the vanilla Kubernetes agent and was like, just start a job and run in process, so everything had to run serially instead. And as a result, this one is going to end up taking longer to finish. So that's kind of like the live show of what's going on there. So eventually, both of these will finish, and we'll see that Magnetic Fossa will have taken longer by the time it makes it to success than Gainful Collie will have. Cool. So that is the end of the show, really. I think a few other points that I might want to make. You can check in the docs. The different execution environments are listed under orchestration. So if you go to docs.prefect.io, you can click on this orchestration tab at the top and take a look at both a deployment tutorial, which covers in more depth, especially some of the like token stuff that I glossed over, is definitely in there. So I definitely recommend taking a look at that if you haven't played with Prefect Cloud much before. But then all of these different execution environments in here. So we took a look at Dask Kubernetes environment, right? But there's a couple other ones in here, including Kubernetes job environment, which works similarly to how we saw the agent, you know, in its natural state does things. But for this, you can provide a custom job YAML to define how those jobs should actually be run. So you have all the power of configuration of your Kubernetes job. Fargate task is for Fargate. And there's also this Dask Cloud Provider environment too. I will say, even though I'm talking about all of these right now, that we are making some changes, particularly to the Dask environments, to try and make them a little bit easier to use, to rather expose the executor quargs more obviously, as opposed to kind of like splitting them up between the executor and the environment. So there's definitely some work going on about that, particularly by our beloved Dask expert, Jim. So thank you, Jim. And you will see a couple improvements of that kind of like coming out slowly over time. You can still use your environments now if you're using them. And I also want to point out that the storage options are also listed in here on these docs, which are now slowing down. My computer maybe is the one slowing down. But that is what where you'll see all the other storage options. I use Docker storage this entire time, but again, you could use GCS storage, S3 storage, etc. instead. So that is that. Again, the walkthrough guide, or like the companion guide here, has all of the code that I ran today, so you can definitely take a look. Maybe I'll do another little reshoot of my Helm debacle, but hopefully the directions can get you pretty far, actually. If nothing else, I did do it earlier today, right? But you didn't get to see it. But other than that, hopefully this gives you a gist of, how to set up this execution layer, how to do some of this work, what the benefits are of using some of these environments that exist when you interact with Prefect Cloud, that you can kind of like take some of that work away from you. Fundamentally, your execution layer is something that you have, control over, but also the result is like responsibility for, right? So this is fundamentally the concept of the hybrid execution model, which is important to Prefect, that Prefect Cloud, we can do all the orchestration stuff for you. You can trust us on all of that. We'll, be always up, etc. But the actual place where your code executes is under your control. And this is super beneficial for people who don't want their code or data to be known by, some other entity. That's like the perfect setup, right? That's the idea of the hybrid execution model. But there is, as a result, a little bit of the setup that you need to do on your side if you want to take advantage of these bigger execution layers, these like scalable execution layers. So hopefully this, if you were feeling nervous about it, this stream will show you that a little bit about it, give you a little bit to get your feet wet. Again, we have another blog post for the AWS people if you want to take a look at what it looks like in AWS. And if you have any other questions, you definitely should hang out with us on Slack or on GitHub, and we'll be happy to answer them. And other than that, looks like the chat is mad I use kubectl instead of kubectl, so sorry. You will have to draw your line in the sand yourself and decide if you're a kubectl or kubectl person. There's probably a couple other versions of that too, so I'll let you decide for yourself which side of that you want to be on. But other than that, thanks for stopping by, and hopefully this was useful to you, and I will see you next time. Bye, everybody. Let's send you off with the video.